and coinbase, how we transform the transformation Web3, which we improve the speed, scale, and efficiency. Talk about how we do the migration, talk about the impact and the future. All right, the first mission in Coinbase, we are the Coinbase mission is increase the economic freedom in the world, and just translate to machine learning training platforms mission. We're focusing on improved MLE scale velocity. We're making sure MLEs can build a scalable training model. We can improve the cost efficiency for our training system. Give you a short history of machine learning in Coinbase. Probably could be a story of any fast-growing company. We started with the first machine learning model in 2017. We're using this I think it's the ATO user risk model, which is talking about if you should transfer money to this suspicious user, right? And then in 2020, which is the last bull run, we introduced a package called EasyML, which is helping our machine learning engineers build the model faster. In 2020, we also built our internal feature store. 2022, we introduced the Easy Tensor, which is better suited for our recommendation system or model. 2023, we introduced CBGPT. As you can tell, the name is about GPT helping internal or external chatbot or internal tooling. In 2023 Q3 last year, exactly the same time, we joined Ray 2023, and we were interested in this tech, and we decided to move our train and serve from our in-house solution to Ray. And by Q2 2024, we finished everything on machine learning serving to move to Ray, and we just finished our training and batch prediction, migrate everything to Ray. We're also investigating how to use Ray for fine-tune and serving. That's a brief history of our machine learning system. Some use cases are predictive. We just talk more about predictive ML, but some use cases like logging ATO, say account takeover if your account is stolen. As there are a lot of fraud in crypto area, but we try to block this. Fund transfer, withdrawals risk, and risk of external Ethereum and Bitcoin wallets. We also have some like notification optimization. We have this assets you might interested in, asset you might like, or we also have something like related to CBGP chatbot or customer service experience. Yeah, that's the overview of our machine learning. So go back to Ray and talk about this improvements or our achievements. We talk about three areas. First is the iteration speed or data velocity. So in the sagemaker based area or the era, that go back to before we moved to Ray, we just realized this take you a lot of time to wait and then go to doing the iteration. So the typical flow here is the MLE machine learning engineers make a PR and then build a Docker and push it to ECR because sagemaker required to have a Docker image, right? And then once you have this built and have a ECR link ready, you can use this as a link to send to our internal service and then trigger a sagemaker training job. We just realized this takes you up to like 2 hours to prepare this thing and then see how your job is working. That's super slow and it's just crazy. Sometimes people just feel, okay, maybe I just work on the feature instead of like work on the model, because who knows if my PR will work or not. And if I do like 3 or 4 times, that's a whole like day have been passed, right? So why it has like so long iteration time? First is because sagemaker requires, or at least our infra requires to have a Docker image. Docker image is a very heavy component, and we think it should be as lean as possible, but Docker image is trying to build everything inside of it, but actually when you are training a model, especially when you are having like 20 models running on using the same Docker image, you probably want to have a separation. So MLP platform maybe just maintain a small one, and then people can just use their own way to control like what actually to plug into this Docker image. But it's kind of impossible. So if you're looking at the screenshot or the picture, you'll see like in the Docker image, we used to have like model artifact, Python model code. Right? We have all the util functions. We have this pip install list. Everything is on it. We have the CUDA. We have the Python version. We have all this information. But actually, what we want to do for machine learning training is actually a very simple one. Just Docker Python version, CUDA version, and some like AWS CLI, which is essential to move some data from S3. Other things could be added as a plugin at the runtime instead of like pre-built into the Docker image. Yeah, that's the actual reason. And how to achieve this, moving to Ray, we're using this new workflow. So we can create a working directory with the training logic. If you're seeing the screenshot, you can call it basic ML, basic model.py, right? We can let you to build some local zip file or wheel files, and then we let you to write a config YAML file. Using our internal CLI wrapper, we can trigger the job using this information. Very simple, and yeah. And give you an example how we do this. If you are just having a basic model, just let's say Python, and you train any model, what you need is just three files: a build file, this py file, and this config YAML file. And you can trigger it immediately, and in the snap, you can see it's running on your Kubernetes cluster or the Ray cluster. Yeah. And then after this model is finished training, we can push this model artifact to MLflow and then go to the server. So give you a look of what the YAML file looks like. It's pretty similar to what we have for Ray YAML, config YAML file. We add this thing called Pi module part. We let you to build your local wheel file, and then add this local wheel file to send to remote, or you can use this PyNet, which our repo called PyNet. But basically, like telling, like, okay, what's the remote one, which is already checking the code at, and then you can either use the remote one, already checking master branch one, or you use your local branch one. So your local branch, use your build file to build a local zip file or wheel file, and then submit it directly. You don't need to wait to say, okay, go through the whole loop, build Docker, and then go back, right? To have this ESRD to trigger the job. So it's super fast. It's just like, if you don't change your code on this like wheel file or zip file, it probably just take you like a snap, like 5 seconds to trigger the job. If you do need this, then depends on how big your files are, but probably it just take you 2 or 3 minutes because you eventually upload this wheel file, and that's the recluster understanding. Yeah. Another thing Ray can help, or Ray actually helped us, is the GCS. So instead of, if you trigger a job on SageMaker, you probably want to wait a little bit when say, okay, this is a Docker file, and then put the Docker file, create an instance, and then install everything, right, into that instance and start it run. But we have a long-running cluster, so most of our files are cached in this GCS. So that's why you can trigger the job within seconds. It's not like you need to wait for installation of these pre-built packages. Yeah, so that's a before-after comparison. Before, we took 2 hours for a single change. Most of the time, it's just building, waiting for a Docker build. Right now, we use, if you need to make a code change, shared code change, you take 5 minutes. If you're just like local, your main logic change, you just get the results in like 5 seconds. Yeah. Another thing is about scale. Yeah. So for SageMaker, most likely a SageMaker training job is using a single instance, and our system used to be very heavily based on SageMaker training job, so it's always at a single instance. Yeah, and we use some tree-based models. Used to use some tree-based models for tabular data. The working flow is like this: we have the raw data, maybe from Kafka, somewhere, and then go to Spark, Snowflake, and then process, either dump to S3 or not dump to S3, pass it to a training job. And we do some last mile data transformation, say some one-hot encoding or something like that, and then go to machine learning model, actually goes PyTorch or something secular, and then go to MLflow. The problem is single instance is like vertical scaling, not horizontal scaling. So, so definitely you cannot get any more like memory, more than maybe half terabyte of memory, because there's no instance available, right? Another thing is like, what if we just distribute your job on SageMaker? I think the problem is like SageMaker's distributed training is basically for tabular data, it means you need to use PySpark. So that means you need to build like two things. First is a PySpark to process your data, and then dump to somewhere, and then pick it up by a machine learning model like PyTorch. Yeah, that's it's like not a single step. It's a multi-step scaling. Yeah, and also when we were researching on this distributed job on SageMaker, it doesn't support a tree model, which we must use before we fully migrate to other models. So under this limitation, we're trying to use instances with largest memory, which introduce huge resource waste, because the CPU and GPU they provide with this memory are basically wasted. We don't actually need this. We just need this memory to keep our data, processing data. What we actually need is horizontal multi-step scaling. Okay, so moving to RAID, the thing is like we use RAID data to read the data from S3 or data sharing. Data sharing is an open source protocol from Databricks. We rewrite this easy tensor to make this pre-processing and PyTorch training distributed. We also rewrite this last mile data transformation using RAID data's map bash function. So what we can do right now is we can use TB level of tabular data for training. We use billions of rows. Our data size maximum is like 50x. And previous max, we use S3 and data sharing to connect Spark and RAID, which Spark is for our data processing. We have cluster with over 70 workers, sometimes more. The last mile data transformation dropped from 120 minutes to 15 minutes because of data, RAID data, distributed data processing. Yeah, so actually we got a bottleneck here, saying when we are trying to read the data over 100 gigabytes from Spark or from Databricks, we realized, okay, we just call this we assume we can pass like 1 terabyte data from calling the API, but using this read Databricks table. But we realized the backend is sort of by this Databricks API, only 100 gigabyte data can be passed. And we directly asked the Databricks team, is it possible to let us to pass like 1 terabyte data? They said no. It's impossible. So we realized, okay, that's a bottleneck. We must use S3, and then probably, when you are doing the dropping the data to S3 and read back to RAID, then you have a lot of resource waste. Maybe if you just forgot to delete the file, and you have like a terabyte data living S3 forever. So so what do? We introduce this RAID data sharing table, this API. Just provide your profile. I think this is called profile in data sharing, and then say how many rows you want. This could be, 1 billion row or whatever. We achieved this using this one, and achieved reading 200 gigabyte of data in the API within 2 minutes. It's pretty fast. The the backend is actually let's drop it to a temporary S3 bucket and then read it back. So it's so on the surface using API, but the backend is actually using some reading from the disk, and you can use multiple distributed way to read this. So it's super fast. Feel free to try. After 2.33 is available on the page. So before typical cases that we use is P3 and 16x large. A lot of GPUs, a lot of CPUs, a lot of memories, but very, very expensive. Right now we go back to use G5 8x large, A10G GPU, so it's relatively cheap compared to before, and that's what we have. We did some optimization to use data metrics, like logical. That's the concept of logic CPU, GPU utilization to guide our Kubernetes to scale. For some reason, we cannot use Kubernetes, so we use this hack to use this logic CPU, GPU utilization to guide the scale up and down. And we provide a cluster with different CPU GPU ratio for different cases. Sometimes as CPU intensive, you probably want to have higher CPU rate. Then sometimes you just more GPU as suits your case better. The last one is resource sharing and the cost efficiency. We talked more about this hyperparameter optimization thing when we're talking resource sharing. So if you see the graph on the right side, that's how SageMaker or typical machine learning workflow use doing the HQ. So you read the data first, and then do whatever transformation you want, and then trigger a PyTorch or XGBoost training. Multiple jobs are running in parallel on different machine, and then you report the result to some controller and see which one is getting better performance, and then the worst one will be killed, right? Because you assume it won't give you good results. But actually think about this, why do you want to read this S3 file 10 times or 20 times? You just need to read them once, do the transformation once, and then trigger 3 jobs in parallel. Right, that's how RayTune help us. So when we're sending a job to Ray cluster, we will use runtime environment to cache in previous job, which is So when we are doing the hyperparameter optimization, it means all this can be shared, and we don't need to run this multiple jobs together, and you can scale it when you are going to the training stage instead of at the early stage of resource. Another thing actually for resource sharing is, as I said, we have the long running cluster. We have the scale up and down. The thing is, when you are triggering a job on a single on SageMaker instance or some other instance, you need to wait 5 to 10 minutes to get it ready for you to trigger the job. But moving to this, you have all this cache on the GCS, so you don't need to wait this long time. And one job is waiting 10 minutes, and whether you have multiple ones, that's all saving all your time and improve your efficiency. Yep, that's all the benefits. Talking about the migration and results. So what we do, we decompose our Docker image into multiple components and then pushing them to our internal pipeline. We set up this Ray clusters on Kubernetes, and then have all kind of DNS, S3, private link, whatever connections. For a single instance model training, just say you have a job, you just want to reproduce whatever you have before. You just have this Ray-int or Ray remote and give it moving to a single Ray task, right? And then run this Ray task inside of that worker node, right? And if you are, which makes your transition very fast, because you basically just add a wrapper outside. And if you're thinking, okay, my model is limited by SageMaker, I need to do horizontal scaling, then you need to reconstruct your data connection, like you can read data, then rewrite your data transformation, rewrite the job using retree. And for HPO, it can support both cases. Yeah, the full migration took us like 3/4-ish. We finished everything, and we're actually closing our SageMaker training job this week. Yeah. Some challenges we faced during the migration. There are many, but first is how to scale, how to do this logical CPU, GPU job supervisors. Basically, you don't want to kill your cluster or remove this instance. If you have like one single big cluster running multiple jobs, you don't want to reduce this number of workers while there's still one job or two jobs running. So you need to use a concept called job supervisors. Always monitor that one to see, okay, I only scale down when everything is done. Otherwise, you're just removing something sitting in memory. That's a big problem because you cannot reproduce. Maybe you cannot. And using this logical CPU GPU, which say when you are having high logical CPU GPU, that means you need the resource to scale. We have this problem of reading data from database, so we resolved it by introducing array data sharing. Yeah, and also the MLP and MLE ownership separation. Before, it's like everything mixed together. Right now, MLP only maintains the cluster and the base Docker, and MLEs are responsible for all this customized code and your package. Like you need to resolve your version conflict. You can override something, but you need to make sure your code and your pip installed package versions are aligned. We also introduced some like job status notification. So when you're triggered a job, once the job status change, we're just always ping this job, and this status changed, and you got a notification, either email or message, Slack message, so you can fast iterate and just monitor your job. Yeah, this is a summary of what we have speed-wise from hours to seconds, size 50x billion rows PB data, cost, we are sharing the resource, and even the instance cost dropped by 20% because of the surcharge. Yeah, and this is our chart from MLflow. I made a screenshot. You see, like before, you see, like because of introducing of HPO, we have a significantly high number of model training compared to before. That's the benefit of building Ray. We used to have HPO like setting using SageMaker, but that's super expensive, and I would never use it because someone which come and find out say stuff that's too expensive. Yeah, and further improvement, future improvement. We're doing the test at the job level, but not the task and actor level. Eventually, people, MLEs want to just take a look at this actor's improvement, but you don't want to read the data and wait for maybe 20 minutes to process, or maybe whatever minutes to process this. You just want to pinpoint on this task and actor. The CPU GPU efficiency utilization monitoring, and this clusters further scale up efficient CPU and the number of CPU and GPU setting, which need to provide some guide to our MLE state. You need to maybe reduce your number of CPU to fractional, maybe 0.1 instead of just using 1. And also add this LM fine-tune support. Yeah. This is a term we use today, ATO, ECR, things like this. That's all about what I want to talk about today. We are hiring MLE, MLP roles, and we got a lot of support from Recore, Redata, Retrain community, Rahul, Jiajun, Matthew Chen, Justin. They provide a lot of feedback guide to us. Yeah. That's all.
Question. So do you also use Ray for serving the model?
The question is, do you use Ray for serving? Yes, we moved our machine learning serving to Ray to 100%.
That makes a lot of sense. And also, I know there's, in my experience, that there are different model training purposes. Like sometimes you just want to try new model. Sometimes you have established the pattern of retrained model with some different conflict with some new data. Like this platform is just more for the first purpose or the second purpose?
The question is, this retrain platform is for like experiment training or some like reproduce retrain thing, right? We don't separate this. We all use the same CLI or command to trigger the job. It more depends on how you write Airflow dApp or something, or how if you want to train from local or train from an Airflow scheduled job. We use MLflow to control which job can be used to for batch prediction or for production serving.
Thank you.
Sorry.
Hey, sorry if I missed it, but where do you publish like trained model artifacts when you're done with like an experiment?
The question is where you publish train model artifacts. We publish to MLflow, internally hosted.
Yeah, I was just curious. You said that for your Kubernetes cluster, you use Datadog metrics or something like that. Could you elaborate?
Yeah. The question is, are you using Datadog metrics to guide the Kubernetes scale, right? Yes, we do. The reason is because we have a layer built on top of EKS, the company infra layer built on top of EKS. So you cannot directly touch EKS, but you must go through this layer. And this layer actually have this Datadog agent to monitor all of our EKS clusters. So yes, and then we add some customization, collaborate with our infra team to say, what is this, some customized. Oh, so we actually pushing this data, this matrix to Datadog, right? And then when we are guiding this cluster to scale, we can use this custom feature back to what's called HPA, horizontal pod scale. So that's a collaboration.
Good question. So I remember like we talked about the migration works. So how many Titan there were used to be, and then on the platform that they should do microservices to migrate all?
Do you mean like how many engineers in my team to
No, like how many tenants there used to be on your platform? I assume that there might be like different teams on your platform using the SageMaker for training. So so how do you do a migration for all of them? Like do you have like some automated scripts, or is it more like microservices?
The question is how many models or engineers are working on model trainings. We have 15-ish engineers working on the traditional ML models. How we achieve this, I said, if you just need to reproduce your model, what you need is basically add a read.remote outside of your model, right? That migration is pretty simple. But if you want to have your model performance better, then you need to rewrite your code.
Yeah.
So we just ask them to move because the cost is so high. Yes.
Did you get any bottlenecks in migrating the last mile transformations to Ray data? Like maybe some operations weren't as performant as they have been previously?
The question is, do you have any bottlenecks moving your last mile data transformation from SageMaker to Ray? There are a lot. So we have a couple of hundreds of last mile data transform functions. They're not implemented the same way. So most of them are similar. So I myself rewrite most of them myself. Try to, for map batch, you need to make sure it's like always using pandas or NumPy to do this because of vectorization. Rewrite them and then set up an example if you have something you want to migrate. Then for large models, right, you need to rewrite your leftover functions. But that's a lot of work we have done on this migration.
You mentioned that when you move to RAID, you don't need to do any PRs, you can just submit the job. Can you elaborate a bit on that? Does that mean there is no controls, I can just push anything to production, or was there a different system before?
The question here is, because we removed this PR request, is that possible we just push whatever model, whatever things to production? Actually, no. The reason is we used to use PR to front load the control, right? But when we are moving this, security and this convenience is always conflict, right? So we move this control to the ML flow layer. So you can drop a lot of things to ML flow, but when you are deploying through Racer, you must get a PR, and you must have show me this link and show, okay, this is triggered from a production pipeline instead of from your local. Does that make sense?
Yeah. Thank you.
So the pre-processing on existing data set makes sense. Did you guys also leverage the array data pipelines to build derived data sets? Something to persist and sort of use for the future?
The question is, do you persist some of your data transformation thing? We do some of them, but not at the data transformation part, because you read the data and you, based on the reading, you process it. But we do some encoding